Hey guys, this is Michelle Kittner from the Gulfport School District, and in today's video we're going to be talking about scale drawings. By the end of this video, you should have all the tools in your toolbox to be able to create your own scale drawing. The standard that goes with this video is 7.G.1. The vocabulary that we're going to be discussing today is scale drawing. We have to know what a scale drawing is in order to create one. Scale and scale factor, those are the tools that we're going to use to create our scale drawing. This is a picture of one of my absolute favorite places. It's a waterfall in Middle Tennessee, and I used to go here a lot in college. We would hike around up top, swim down at the bottom, stand under and behind the falls. It was just a lot of fun. So I have a picture of this in my classroom on my desk. And let's say you came in one day and you were like, Miss Kittner, that is such a cool place. Why don't you make a big poster of that and put it on the wall? I'm like, you know what, that's a great idea. So I go and I enlarge it and I print it out. And the next day I come back and I put this on the wall. And you come in and you're like, Miss Kittner, that's not the same place. That's tiny. That looks like you could step over it. It looks like a puddle or a stream, and then you could just step over the rocks. It doesn't look like the same place. I'm like, you know what, you're right. So I go home and the next day I come back and it looks like this. And I've put that on the wall. And you're again like, Miss Kittner, still doesn't look like the same place. Now it looks huge and not like something you would want to stand under. It would hurt. I'm like, okay, you know, you're right. So you, in all your math knowledge, say, Ms. Kittner, you need to grow or expand or enlarge that picture in proportion. It needs to be proportional. And what you mean by that when you say that is you need it all to grow at the same rate. You need it to grow horizontally and vertically all at the same rate. So the next day I come in and I have this on my wall. And you say, you know what, Miss Kittner, that is it. Everything grew at the same rate. It's the same picture, just bigger. Nothing's distorted or out of proportion. Like, cool, I really like it. Thanks for the suggestion. So what a scale drawing is doing that same thing, but instead of just reprinting a picture, we're going to draw. You would be drawing a new drawing. Based on the measurements. But the definition of a scale drawing is a drawing that shows an object with its measurements in proportion to the actual measurements of the object. So here's the original picture. It was originally 4 inches by 3 inches, and I blew it up and enlarged it and made it 24 inches by 18 inches. So what I had to do is I had to say, okay, this piece is 3 inches. There's about an inch, and there's about an inch. And so over here, I still have to have those pieces still have to be about at a third. So it'd be about right there and about right there. And then on the bottom, it's in fourths because this is 4 inches. So here's an inch, here's an inch, and here's an inch. Again, over here, those have to be in about the same place. So it'd be about right here, here, and right here. And what scale drawings do is they tell me that if this represents 1 inch, then this piece represents 1 of these inches. These two pieces represent the same. So how many inches of the 18 inches are in this piece? Okay, that's the question we're going to be answering. And that should be the same number of inches as are in this piece. Okay. So I knew that when I blew up the poster, I had an 18-inch space that I could put it in. It was 18 inches tall, so I knew that's what I was going for. So I said, okay, I have 3 inches in the original and 18 inches, and I'm going to create a ratio of original to new. In this case, the new is the enlargement. The new is the enlargement. So my ratio of original to new on the height was 3 inches to 18 inches. So I put that in a ratio table right here. Now, I just want to fill in this ratio table. I just want to find equivalent ratios. So 3 divided by 3 gave me 1. I want to take this to the smallest number I can. I want to get these numbers down so that I can work with them a little bit better. divided by 3 gave me 1. So if I divide one of the numbers in the ratio by 3, I have to divide the other number by 3. 18 divided by 3 gives me 6. So my ratio of 1 to 6 is actually going to be my scale. It's the smallest numbers that I could bring this equivalent ratio down to. So my scale is now going to be 1 inch to 6 inches. All right, let's get rid of some of this extra stuff right here. All right. So let's go ahead and finish filling in this ratio table. If there was 1 inch that represented 6 inches, then 2 inches in the original would represent 12 inches in the new. If each of these pieces is 6 inches, 6 inches, 6 inches, and 6 inches, then 2 of them together are going to be 12. 3 of them together are going to be 18, and all 4 of them together are going to be 24. Okay, so we just filled in the ratio table, and then we can see that it works. That 3 inches here goes with 18 inches here, and 4 inches here goes with this 24 inches over here. The scale factor is just what did we multiply the numbers in the original drawing or the original measurements? What do we multiply those by to get the new ones? Well, to get from 4 to 24 and 3 to 18, we multiplied by 6. Now, a key to scale factor is you always have to be in the same units. So if you were in inches for one and centimeters for the other, it wouldn't work. They have to be the same units. Scale drawings can go the other way too. They don't just have to blow things up. They can shrink them down. They can reduce the size. So here, maybe I had a poster in my room and I just wanted to create a smaller picture that I could carry around. So we're still going to follow the same pattern. We're going to see what did we do to the original to get to the new. The difference now is that the original is a reduction. So here I would have 24 inches and I want to get it down to 3 inches. I know that I want to reduce it down to 3 inches. So I want this piece to be divided into thirds again. And now what I'm going to ask myself for the reduction is how many of the 24 inches do I have to squish down into each of these inches? Okay, so I'm going to squish down from 24. I have to fit them into 3. I've got to squish them down. Got to divide them by 3 to get down to 8. Divided by 3 gives me 1. All right. So there's my scale. We just found the scale. And then once we have the scale, we can do anything. So I have my scale of 8 inches to 1 inch. Okay. Let's finish filling in the ratio table. So if I have 18 inches here, this is going to be, I've said that each of these pieces, I'm going to have to take 8 of these inches and squish them down into 1 inch over here. So I've got 8, 8, and 8, 8, 8, 8, and 8. Let's erase some of this extra. All right, so if I had 16 inches, that would be 2 of these. It fills in 2 inches here. If I have 32 inches, all 4 of these, then it goes to 4 inches here. If I had an even bigger one and it had something that was 40 inches, then it would take 5 inches on the reduction. My scale factor on this, it'd be easy to look at this and say, oh, my scale factor is going to be 8, right? Well, it's not, because 8 times, if I want to go from 32 to 4, 32 times 8 does not give me 4. 32 divided by 8 gives me 4. But I'm not looking to divide by anything. I want to multiply. So what can I multiply by to have the same result as dividing by 8. Remember, fractions are just the same as division. So I can say 32 times 1/8, which would give me 4. So my scale factor is going to be 1/8. All right, let's look at the definitions for those. A scale is a ratio that compares the measurements used in the scale drawing with the actual measurements. So in our example, it was 1 inch to 6 inches and 1 inch to 8 inches. Remember, ratios can be written either way. So on the last screen, I had 8 inches to 1 inch, 1 inch to 8 inches. Remember, ratios, doesn't matter which order you write them in, as long as you know that you're going from small to big or big to small. The order is consistent. The scale factor is a constant of proportionality. What did you multiply the original by to get to the new? And in our examples, that was 6 and then 1/8. Okay, let's work through this example to make sure we understand. Here's our steps that we're going to follow over here to the left. And our example is, this is a scale drawing of a football field. A length of 1 inch in the drawing represents 40 feet in the actual field. Find the dimensions in the actual field. Okay, I shrunk it down a little bit so we'd have some room to work. Find the scale. Well, in this one, it gives you the scale. A length of 1 inch in the drawing represents 40 feet in the actual field. So we know that our scale is 1 inch to 40 feet. Now, what's the scale factor? Remember, scale factor, it has to be the same units. We're looking at inches and feet right now. So we don't really have a scale factor unless you were to convert inches to feet or feet to inches. But we're not going to do that. Next, it says to set up a ratio table. So what I did is I took my scale and I put it in the first spot. I always try to put my scale in the first spot. And then I just filled in these numbers to see what I was going to need. Use equivalent ratios to fill in the ratio table. Let's do it. For every 1 inch, there's 40 inches. So if we have 2 inches or 40 feet, we have 80 feet. Remember, 1 inch to 40 feet. Right here. 3 inches would give me 120 feet. 4 inches would represent 160 feet. 5 inches would represent 200 feet. 6 inches would represent 240 feet. 7 inches would represent 280 feet. 8 inches would represent 320 feet. And 9 inches would represent 360 feet. How did I do that? Just multiplied. If there's 1 inch on here, that means I have to expand that piece to be, every inch has to represent 40 feet. Okay. I could look at each of these little pieces too and see how far away the yard lines have to be, or the hash marks, how far away they are from each other or how far in they are, just by saying for every inch on this drawing, I have 40 feet on the field. So now we could take this and go out in a field and draw it. But we need to draw the new sides or answer the question asked. Well, the question asks us to find the dimensions of the actual field. Using the ratio table, I knew that I needed to look at the 4 inches for the length of, or the side, the end zone side. How long or how wide is the end zone going to be? And then 9 inches for the sideline. How long is the sideline going to be? So the sideline, if it's 9 inches, then we have 360 feet. 9 inches in the drawing gives me 360 feet. And then the length of the end zone, on the drawing is 4 inches. So on my ratio table, I found it here. On the actual field, it's going to be 160 feet. Now, I didn't fill in these others on this ratio table when I brought it over because it doesn't really matter. We didn't need those numbers. So now you could go out and you could draw a football field on a field, or you could even make a smaller one in your backyard using a different scale. All right. Go try it. Try and draw a ratio or a scale drawing using ratio tables.